Thank you very much for joining today's webinar about data notarization as a key element for securing the energy infrastructure. I'm here today with Patrick from Tributech, and my name is Jos from Welotec, and we'll guide you through this webinar and introduce the concept of data notarization today. Before we start, I'll have a short view on the agenda. And it will start with the introduction of Tributech and Welotec. Then we go a little bit in use case of remote monitoring of substations, primary and secondaries, expand a little bit use cases, and what kind of data communication is available there. Then we go into the basics of data notarization, data tampering, threat scenarios, and what can happen. We look into possible solution architecture, have a great live demo. I'm very excited to see. And then we talk a little bit about the partnership between Tributech and Welotec and how the combined solution will look like. At the end, you'll have time for questions and answers. Please feel free to ask the questions at any time during the webinar. So this will be possible through the Q&A section within the Zoom app. Okay, Patrick, over to you. Talk a little bit about Tributech.
Yeah, thanks for having me in this webinar. My name is Patrick. I'm CTO at Tributech. A few words about us. We established Tributech in 2018. We are headquartered in Europe, in Austria, and we are currently active in the markets of Europe, the UK, US, and the Middle East. Over the last years, we have built a global partner network. Some of them you see here on this map on the right side. And we offer our technology through a channel model to distributors and integrators, working with them in the different regions to be able to serve our customers on a global scale. And for our technology platform, for the data notarization and integration, we also have a patented technology for securing data integrity from source to consumer, which we will talk more about that at a later time of the webinar. Then please go ahead.
Thank you, Patrick. A little bit about Welotec. So Welotec was founded in 1969, more than 50 years ago. And we are focusing on industrial automation. Soon later, or 30 years later, we started with M2M technology for communication and wireless data transmission, so all about data, going into IoT and M2M applications. And since 10 years now, we're working in edge computing and the combination of edge and cloud computing to create an infrastructure to use data. We're working in different vertical markets. Today, we are talking about energy infrastructure and how to use the solutions there. But together with Tributech, we also work in other vertical markets like machine building, where we can provide the same solutions and the same concept as the standard technology. Slide, please. Talking about the use case and what happens there. So we need to connect more and more substations as the heart of the power grid. Therefore, we need more data communication, and we need to make sure that the data is accurate and the data between the systems is not manipulated on any part. The same happens for secondary substations. So also secondary substations need to be connected. They need to become the intelligent part of the distribution grid, not only for monitoring low voltage and medium voltage sites, but also to integrate more and more parts into that. This is required because we are in an energy transition. And in this energy transition in Europe and many other areas of the world, we are connecting more and more distributed energy resources to the low voltage, medium voltage grid. In addition to that, we create more and more applications and connected applications. So if we're looking at a typical distribution transformer or secondary substation, we have usually a low voltage side where we can get data from about the sensors. We have a medium voltage side. We can have a SCADA system and can remote control from the SCADA system also over a remote link the grid. In addition to that, there are applications like smart metering, where we have payment data that is transferred over a link to the receiver, which could be different entities than the grid operator and the operator of the network. We have additional IoT sensors. We have e-mobility applications and also local energy storage applications are planned. And all these devices are interacting with each other. They are exchanging data and through, for example, an edge computing device, an edge computer, which is collecting the data, they're communicating with the SCADA or even with the cloud system. Next one. So if you're talking about the risk, this connection is required, but it increases the attack surface. And this is increased through more and more connected systems. So you have more and more places and attack vectors that can be attacked. And so probably everybody that is working in a critical infrastructure knows that cybersecurity is crucial. And this means we need to have a very, very secure system, and we need to think beyond firewall. We need to think beyond IDS systems. And we need to understand that many systems that are distributed are also unmanned and remotely controlled. So we also have attack surface from a physical side. Through physical access, manipulation is also possible. So it's very difficult to protect those distributed unmanned systems. Each of them has physically easily attackable surface. Thanks. Next one. So talking about data integrity or talking about cybersecurity first. So cybersecurity, if we're looking at different concepts, we can look at the CIA Triad. And this one is defining confidentiality, integrity, and availability. And this is the three pillars of cybersecurity, and all are very important. So if you have different types of data, different parts of this CIA Triad are most important. And one crucial thing, especially in OT systems, is integrity, I guess, Patrick. Is that correct?
Yeah, I would say so. Yeah, thanks. I would like to talk a bit more about especially data integrity and also give you an idea what we at Tributech are doing and what kind of new security solution you could potentially also introduce within your system. As you also already mentioned, the CIA Triad is defining the three core elements of an information security strategies organization, typically using this model to define their policies and security strategy. But we think data integrity is a topic that is very overlooked and not well covered in all parts of our infrastructure. So what does data integrity and tampering actually mean? In cybersecurity, integrity means that your data hasn't been tampered with, or in other words, that the data has not been changed or was not manipulated in an unauthorized way. And the question I would like to ask, do you think that data integrity is properly protected? We often get their answer if we talk to people that they actually do not know how their data integrity is protected. And I think the reason is because currently we have many passive security controls. We have like intrusion detection system, which help us to identify if an attacker is our system. We have firewalls and access control systems and stuff like that. But we do not have a system that allows us to actively verify if the data is still correct or not. And next, I would like to look at the impact of a data integrity attack and why it's important in our opinion. With current security controls, you typically have a very long time frame to discover an integrity attack. The business impact can be very high, as well as the time to recover can also be very high, which should give you look on that data integrity topic to have a deeper look on it when you modernize your system and your infrastructure. And when we talk about the attack vectors, there are two different angles you can look on it. On the one side, you have potentially insiders that can attack your data integrity when employees or contractors like third parties or suppliers that has access to your system, they can actually access your database, your network infrastructure, and they can potentially also tamper your data. There were also many cybersecurity incidents in the past where some employees or contractors manipulated data on a database level, for example, and this can be undetected for a long time because it's actually authorized access, and you detect it when it's basically too late and the damage already happened. And another angle is the external data tampering attack, when you have an unpatched system or server, when there are zero-day exploits that can be used, or when attackers try to social engineer your employees, they are able to gain access in some part of your systems and then also have the possibility to tamper different kinds of data and to do harm to your business. And we currently see many different challenges in the protection of the data integrity, where currently no proper security controls in place. One thing is the protection across different system layers, especially in IoT and OT environments. When you collect the data for remote monitoring, the data is traveling through many different system layers, and you currently do not have the ability to properly protect data integrity across all these different system layers. Another thing is the detection of data tampering. You may detect that an attacker has gained access to your system, but if you look at the data itself, you actually do not have the possibility to detect if this data point or data set was tampered after you have detected an attack. You probably need to manually verify if it's still valid or not. Another point is the mitigation of human error. If someone accidentally breaks some data and he's afraid to report it to his manager, then you also have the problem, how do you detect and mitigate potential errors that accidentally happened. Another point is the recovery from cybersecurity incidents, for example, with ransomware. That also already happened in the past, that an attacker installed ransomware, decrypted your data, you pay for it and get it back. And how do you know after the attack that the data wasn't being manipulated? How can you restore your business operations? You also have the lack of detection, which data is still correct or which data is malicious, and that also slows down your recovery process of cybersecurity attacks. And another problem is the detection of false data injection, where attackers try to influence your processes and your actions you do on data by injecting false data. And it's also often the problem that companies detect it too late that false data was injected where already something bad happened because they used the fake data within their systems. And the last point I want to mention is the long-term data integrity protection for data that you use for longer time frames. This is especially relevant, for example, for machine learning when you use training data from multiple applications, or another example would be the healthcare sector, where we use data for decades. Think of like someone is tampering your medical data and you get the wrong medication. You have the risk that you can die because of that data tampering. And all these issues is not just some hypothetical future scenario. These attacks are already happening. We already have collected a huge list of that, and I also have two examples here today. One example was a blackout in the US power grid, where they hijacked sensor data, manipulated them, and they basically simulated energy providers and consumers to disbalance the grid, which then forced a blackout of the system based on these hijacking and data tampering. And another example is the canonical pipeline attack, which was a ransomware attack, which had a huge disruption on their operations and also a huge financial impact. And one of the issues was that the attackers were also able to tamper the company's syslog data, which prevented them to early detect that they were affected from ransomware, which could have a huge impact in detecting the attack earlier and preventing financial damage to them. So there also data tampering was a huge issue. And beside the potential impact on a business, there are also many security regulations in place, or also upcoming security regulations targeting critical infrastructure, but also companies in general. In Europe, one of the most important regulation is NIS2, the Network Information Security Regulation. It applies to companies with more than 50 employees and more than 10 million revenues. And it will be applied to 18 different sectors, which also includes the energy sector. The fines are very high, similar to GDPR. They are up to 2% of the annual global revenue of a company, or up to 10 million euros, whatever is higher. And it's already active since January this year. And we are currently in the phase where the national countries have time until October next year to implement this regulation on a national level. And this regulation is also requiring companies to implement security systems to detect cybersecurity threats and to handle incidents in a proper way, which also includes data integrity. And there are also many other regulations globally. NIST is also one of these cybersecurity frameworks you may already have heard. It's also used by many other countries and regions as a reference. There is also a new OT cybersecurity regulation in Saudi Arabia. It's already active. It was implemented in 2022, last year. And also the UK has its own cybersecurity regulation for critical infrastructure. It's also based on the European NIS regulation, but it's already active since 2018. So there is also more and more requirements from the regulator, and it also gets more sensitive because you have these high fines. And you are also personally reliable as a company manager for NIS2, for example. So that's a topic that will be more and more important for all companies in Europe. And now I would like to have a short look on how such a data tampering scenario can look like in the critical infrastructure. If we're thinking about the use case, modernizing the energy grid, also collecting data from energy substations, we would like, for example, to collect the data of the transformer temperature. We want to collect energy data. Maybe we also want to collect log data from security systems locally installed in the substation. And one of these data could be the transformer temperature. And when we now collect this data, transfer it to an endpoint, it gets processed, it gets stored somewhere. We have the potential risk that insiders or external attackers can target our system and can manipulate this data. And we now use this data in our applications for remote monitoring, for looking if everything is running as expected, or if we need to do some countermeasures or some other actions. We have the potential risk that they tamper the data. We use that tampered data, and this then causes a downtime because there was no action taken. We have a financial loss, and if the whole transformer burns down, we maybe also have some issue with staff or other people involved. And you may ask, what should we do now? And what we at Tributech would recommend is that you should not blindly trust your data. You should verify your data before you do any actions. And what we are offering to target this issue is technology we call data notarization, which allows you to notarize data directly at the source to establish a proactive security strategy within your system, which allows you then to verify data integrity across the whole lifetime before you take any relevant action. And with our platform, we offer a solution for data integrity verification from source to consumer, which can be used to integrate different kinds of systems, starting from smart sensors to OT infrastructure and IT applications. And with our technology, you can then notarize the data at source by creating a cryptographic proof consisting of a hash and signature. And we store this cryptographic proof within a security layer where we use an immutable database based on blockchain technology to provide a security layer for data integrity verification that is 100% secure. And we then also offer the technology to distribute the data to higher level systems so that they can consume the data within their platforms and applications and also verify it before they take any relevant action. If we now look again at the same scenario that we had before with the energy substation and the data we integrate into our system, we now add the data notarization platform and create this cryptographic proof from the transformer temperature, which then allows us to verify this data at any point in time in our system. And when we have again the same scenario with the attacker targeting our system, manipulating the data, when we now use the data within our application, we can perform the verification process and get immediately notified that the data was manipulated and tampered by a bad actor. And we can now detect the data tampering, we can avoid the downtime, and we have additional information available to analyze the root cause of the attack. And on the next slide, we see a reference architecture from both solutions, which showcase how you can implement this technology together. So here we see a Welotec industrial IoT gateway, which also allows the installation of application through a remote container management. And at Tributech, we have it's called Tributech Agent, the product, which also includes a message broker and a connector for common protocols. So you can connect your sensors through Modbus, for example. You can also use it for integrating log data from security controls. And the agent then notarizes this integrated data, creates the cryptographic proof, which is stored in our security layer of the data notarization platform, also integrates the data itself and provides a communication channel for remote configuration and commands. And together, this really provides an holistic solution for secure data integration. Also, Welotec has many additional security features that complements very well with Tributech, like they have an hardware security module integrated, they have an integrated firewall, so it fits very well together. Maybe you also want to add something here, Jus.
Yeah, that's great, thanks. Also, if you're looking at other IT and OT security solutions, because usually we have multiple applications within substation, secondary substation, or e-charging station, or whatever it is. And data notarization is only one part of it. For example, if you use an IDS system, also to understand what kind of protocols are in your network and how it works, you can also notarize the data of the IDS system and run the IDS system on the same hardware platform and deploy it over the same hardware platform. The same would be with the next generation firewall or some kind of other data analytics applications, or even something like visualization or remote control or RTU functionality. So this is on top and doesn't need additional hardware. But of course, you can just install it also as a single application on one device.
Okay, then let's jump to a short live demo. I hope everything works well. Okay. Jos, can you please confirm, can you see the dashboard?
Yes, I can see the dashboard.
Perfect. So now we see the configuration and management interface of our platform. We have here a data source connected, which represents such an energy substation. There is our agent running on the Welotec device. We see it is online. It has different data points like the transformer temperature and also the current measurements, firewall log and other stuff. And we can now look live at the transformer temperature. We also can look into the data audit results where we see that everything is successfully validated. Here we see the last timestamp when it was verified the last time. And I've also prepared another dashboard where we also see here again the temperature of the transformer. And we see that everything is successfully verified. And what I want to showcase now is the data tampering scenario and how we detect it with our technology. Now I want to show you another thing. This is a database explorer. So imagine now that I am an attacker targeting the system. I have root access gained to the database in some way. And I've prepared here an query to tamper the data. So the first part is like I'm loading the data. And the second part is that I then actually tamper one specific value. Now I go back to our dashboard, to the transformer temperature. I switch to the table view. And now I select one specific value. I copy the timestamp here. I replace it here in my query so that I can tamper this value. And when we now execute the query, we have now tampered the data point. We can now go again to the audit results, and we can trigger here the verifications again. And now we see one of these values failed and the hash doesn't match anymore. We have detected the tampering. I've done this now manually, but this can be automated, which is the typical case in a project. So there is the functionality and the interface to integrate this kind of data verification process with your security platform. You can connect also the data tampering alerts into your CM so that you can integrate that in your security systems and in your alerting system to be immediately notified once data tampering is detected. And if we look now at the other dashboard that I have prepared, we see here the tampered value that I have inserted, and we also see here the exact time frame which is marked as tampered, and we are able to immediately detect this data tampering, and we can then prevent potential impact on our business once we have the security control in place. Yeah, that was a short live demo. Now I switch back to the presentation. Maybe I let you start, Jos, what you think about our partnership.
Well, first of all, it's great, of course. So it offers Welotec a lot of possibilities to secure the data of our clients on the basis of our edge gateways. So working with Tributech allows us to add an additional security layer, and especially end-to-end security solution, not only for operational data, but also for security data of other security applications like IDS and firewall. This is something that can be added quite easily and adds a quite large value to the application and security infrastructure. What do you think about this, Patrick?
Yeah, I think that's a very, very good statement. What I would like to add here, we often have customers and partners that are asking what are proper gateways that can be used to modernize our infrastructure, on which things should we look from a security perspective. And it is harder than it looks like in the first place to really get good edge computing gateways, especially when you are looking for integrated hardware security, firewalls, and a proper firmware update management. It's really hard to find good devices, and that's also a reason why we very often recommend to our customers and partners to use Welotec if they are looking for new devices. And what I also very like that it's also an open system where you're not blocked by some constraints of the vendor.
Thank you, Patrick. That was great. Let me maybe add one thing. So what we also do is we have the possibility to pre-configure the devices. We have the possibility to ship it at any destination or nearly any destination globally, so that you have directly the configuration and the required data on it, so that you just need to plug and play it and bring it online, so that you don't have that additional overhead if you are bringing that to your customers. Or if you are the end customer, can directly install it without needing experts or technical guys.
Yeah, I think that's a very important point. We also have a joint customer that has a serial production with the devices, and for them it was also a very important part to already get the provisioning from the manufacturer. And I think that's also a huge benefit that Welotec is flexible on that side to have pre-built images to do some provisioning steps before the devices get shipped. That was also a huge benefit for a trend customer of us.
Okay, great. I think we are at the end now, and we can go to the Q&A session. I see that we have plenty of questions already. Please feel free to ask more. I would do it like this, that I moderate the questions to you, Patrick, or to me, and then we can both answer them. So the first one would be, which types of data are supported? Are there any limitations? Patrick, I think this would be first part for you.
Mm-hmm. We have let's say, generic data integration stack where you can basically integrate any kind of data. And what we also have is pre-built connectors for the most common OT protocols. So it's like just simply configuring a Modbus interface where you define the Modbus register, for example, and then you're able to collect the data from your energy meter. The same thing with OPC-UA. We also support MQTT, and you also have the possibility to implement a custom connector to support any legacy or proprietary protocol you may have in your infrastructure. And we also often integrate not only sensor data, but also log data from security controls, because they are also of high importance from a security and integrity perspective.
Great. Thank you very much. So this was typically interesting for our DSO customers, I guess. I've seen that plenty of them are here. So this would mean that you can have the LV modules and MV modules in your secondary substation just connected to one of our edge computers, have your applications running on it, and you can use the Modbus connector to add the functionality to avoid data tampering through authorization. Next question. What is the typical computing power needed of an edge computer in a substation? I would take the first part and then hand it over to you. So in general, it depends really on the applications that we have. Usually our customers start quite small, that they have a simple protocol conversion. But adding additional features like security, gateway, RTU, and so on. It also depends a little bit if you're looking at secondary substation or primary substation. So usually what we are doing is we are going from into the Atom processor up to a Xeon processor with 8 cores and 16 threads. So a very powerful machine. All, of course, are substation certified IEC 61850-3. So this is a wide range. For most simple applications in secondary substations, we are fine with a 4-core Atom processor with 4 GB of RAM. And this also allows you plenty of space to extend that further in the future with additional applications. Patrick, do you want to add something to that?
I think you covered it already very well.
Thank you. Next one would be, what is the difference between data encryption and data notarization?
Depending on which kind of encryption you mean, if we are talking about TLS encryption, you can secure basically your communication between the OT infrastructure and the backend or cloud system, for example. And then you have the protection of data integrity at the time of transportation. If we're talking about encryption in general, you encrypt and decrypt the data, you use it sometime. And the difference is that we are creating like a proof at the source, which you can use independently of encryption at any point in time. So it does not only guarantee the integrity in the time of transportation, when it's then processed, stored in a database, and loaded by an application again, you can check it against our security layer if the integrity as well as the authenticity is still valid. And it doesn't matter if this is 10 seconds later or 2 years later. So it adds an additional integrity layer on top of existing security solutions like encryption, and they can also be combined and complemented with each other.
Okay, perfect. I think you covered it all. I will jump to the next one. Is there also an application with real-time controllers? I mean, something like using quality indicators of data which a PLC could recognize and make decisions over control strategies. It's a difficult question, quite long. So I believe it's more about real-time of PLCs or RTUs that are communicating with a secondary substation. So how real-time you are, Patrick, with your application?
With our application, we are on the network layer, so we can have a near real-time communication, but we do not have hard real-time like you have directly at the PLC, because we have like things like network latency. And you can use the data notarization technology to protect data integrity in a passive way. So if you have a very high frequent communication, you can implement our technology. So it's also listening to the data flow, notarizing the data, and you can then on the other side verify the data. But you have some kind of latency you need to calculate until you get the verification result. So our technology is designed that it does not influence the data communication itself, and you're also flexible in how you use the security layer. So you can use basically the whole platform for integrating and notarizing the data, or you can also use only some part of the functionality. But it's not meant to be directly in the real-time automation layer of an PLC system, for example. So it's, starting on the network layer, connecting physical systems with the network and securing it.
Okay, jumping to the next question. Is it possible to apply it to a traditional energy application protocol like IEC 104, DNP3, or ICCP?
Yes, I think it's pretty much the same answer as before. It's possible to combine the technology with existing protocols, as mentioned there, and you can install the agent as a passive component listening to the data, creating the cryptographic proofs for the notarization, and you can also use to verify it. But if you want to have to verify it in real time, you need to consider that there is some latency, and this is not possible to really do it in real time. So depending on what you want to do in your use case, it can be combined, or also maybe not if it's really related to real time communication. But in many cases, when you analyze the data, you have longer time periods where you look at that. And even if the tampering alerts comes a few seconds later, it is still valuable to identify that there is an issue with the data integrity.
Okay. Another question. How does a Tributech work when the data alteration is from an end device?
I'm really sorry. What is alteration? Is it like tampering?
I think it's tampering. So if you tamper from probably a sensor or so.
Okay, I think I got it in which direction the question is going. When you implement our technology, you always try to implement it as close as possible to the source, eliminating attack vectors. That's also a reason why we are partnering with Welotec, because they have the possibility to use the hardware security module as a root of trust for storing my key material, for example. And then it also depends how you can connect to your data source to ensure that you have some kind of encrypted communication. So to also eliminate attack vectors before the data enters our application and gets notarized. So yeah, it's then up to the use case, and we also help our customers in designing then proper solutions to minimize the attack vectors on the input side. And it's an important topic to consider that when you design the solution.
Okay, next one would be, what are the limitations of real-time applications and data integrity? I think data tampering is also meant.
Yeah, I think pretty much to some questions before, you have the limitations that you have to plan a few seconds to sub-seconds delay in that. So if you can accept that the data verification is not in real time, it fits for a use case. If you want to have it in hard real time, you maybe cannot use our technology.
Then the question, how is data verified if Tributech cloud is dead or not reachable?
Yeah. Regarding to Tributech, I would say we are in a good state as a company and growing very well. And if some customers having concern if they can use the technology once it's over with Tributech or something happened to the company, we are also open for discussion about legal possibilities to ensure that they have then access to the software. It's depending on the use case and on the project. But if that's a concern, please reach out to us.
Okay. Then how do you integrate that with a serial 101 protocol and a 104 system, which are connected not with the internet, but via narrowband radio systems? No fiber, no LTE, just narrowband communication, which is very limited. I think you would not use it, right?
I'm not sure if I 100% got the question. We also have an C implementation of our agent, which can used on an embedded level. We currently have an own small hardware module, which is called the OM module. It's something completely different to a typical edge computer. And we're also thinking about offering an SDK in the future. So maybe that's a possibility to use it in some kind of these areas that I mentioned in that questions.
Yeah. But if you have no or extremely limited bandwidth, which is just enough for your data, and you don't have internet breakout, you probably cannot use it, right?
We already tested it with narrowband IoT, so it's possible to also have a very low bandwidth required for the notarization. So that's possible. But if you have some battery applications where you want to run it for 10 years battery lifetime, then probably that's too much and affecting the battery life. So again, depending on the application, if it makes sense and if it's possible.
Okay, thank you. I think we are already a little bit over time. And I see that most questions that are now here are already answered in an extremely similar way. So I would thank everybody for joining. It was a pleasure to have you here, and I would be happy if you are joining our next webinar. We have the same session tomorrow morning for different time zone. So if you have colleagues in other regions, for example, Southeast Asia, Middle East, they could join tomorrow. or even Europe. So please let them know. Thank you very much, and hope to see you soon.
Yeah, also thank you very much from my side. Have a good day.
Okay, bye-bye.